Welcome to this explainer. If you're studying computer science or honestly just fascinated by how machines actually understand us, you've probably hit that wall of compiler design jargon. It can feel a bit much, right? But today, let's just take a deep, calming breath. We're going to slowly unpack the really beautiful, simple logic behind how computers process the code you write. We're specifically looking at a concept called bottom-up parsing. There's this incredibly peaceful rhythm to it once you see it, so let's take our time and walk through it together.
Think about how you and I read a book. We read left to right, top to bottom, keeping the whole context of the story in our heads. Well, the computer doesn't do that. It literally cannot grasp the entirety of your if statements and for loops in one giant glance. Instead, it gently gathers up the individual pieces of your code, kind of like picking up fallen leaves from the ground, and it carefully builds them upward into this perfectly structured tree. It's just a quiet process of assembling small, certain truths into a much larger reality.
If you look at this basic concept here, the entire goal of a compiler is actually remarkably straightforward. It's just translating your source program, the code you wrote, into a target program, which is the machine code the computer can actually run. That's the whole shebang. And parsing? Parsing is simply the quiet structural bridge that makes that translation possible. Now, the compilers doing this work can be absolutely massive. We're talking 10,000 to a million lines of code. But their fundamental purpose is just this one elegant translation.
Okay, let's get into Section 1, How Computers Read Code.
In the massive flow of a compiler's phases, notice how the parser is really just one specific step in a much larger sequence. It takes these things called tokens, which are just the most basic words and symbols of your code that were identified by the scanner, and it verifies their structure. Conceptually, it's just building a syntax tree. While the compiler is off doing a million other jobs, like semantic analysis or code generation, the parser's only concern is grammatical structure. So for right now, this little step is the only one you need to worry about.
Moving on to Section 2, From Leaves to the Root.
So when we talk about parsing, you generally have top-down methods and bottom-up methods. Now, top-down parsing tries to build from the main root downward, kind of guessing the structure as it goes. But bottom-up parsing, it is much more grounded. It starts exactly where you are, right at the leaves, the actual tangible tokens of your code, and peacefully works its way up. It doesn't make these massive assumptions. It just looks at exactly what is right in front of it.
And there's actually an incredible power hidden in that humble approach. Because bottom-up parsing patiently waits to see the actual pieces before deciding how they group together, it can handle a significantly larger class of grammars than top-down parsing can. It manages the wild complexity of modern programming languages simply by focusing on the immediate pieces in front of it. It secures a totally solid foundation before it even tries to build the next floor.
Which brings us to Section 3, the shift-reduce rhythm.
This gentle upward building is driven by a really calming, repetitive mechanism. The first move in this rhythm is the shift. Imagine you're organizing scattered papers on a desk. Shifting is literally just taking the next small piece of your code from your input buffer, maybe it's an ID or a plus sign, and gently placing it onto your active workspace, which we call the stack. You're just moving a token from the waiting pile to the working pile. That's a shift.
Then we have the second move, reduce. When the pieces you shifted onto your stack perfectly match a known rule of your programming language, you group them together. You just replace that specific string of symbols with a single higher-level symbol. It's exactly like tidying up that messy desk. Once you have your variable tokens perfectly aligned, you group them into an assignment statement. It's like taking a bunch of scattered receipts and putting them into a single folder labeled expenses. You've just reduced many small items into one structured concept.
So the really crucial point here is that despite the intimidating reputation compilers have, a shift-reduce parser really only makes one of 4 simple moves. It shifts a piece onto the stack, it reduces a matched group into a single concept, it peacefully accepts the finished tree when everything perfectly comes together, or if the code is invalid, it just politely flags a syntax error. And that is it. That's the entire universe of its actions.
Section 4, Finding the Right Handle.
Now, the only real decision in this rhythm is knowing exactly when it's time to group things together. The term for this is a handle. I know, it sounds highly technical, but honestly, don't sweat it. A handle is merely the correct pattern of symbols sitting right at the top of your stack, silently letting you know that they are ready to be reduced. It's just a substring that perfectly matches a rule, and it represents the exact right step to take to work your way backward.
And the act of doing this, of replacing that handle with its higher-level rule, is called handle pruning. You're just recognizing that pattern on your stack, making the reduction, and stepping back to see the slightly bigger picture. You prune the leaves to reveal the branch, and you prune the branches to reveal the trunk.
Let's bring it home with Section 5, one step at a time.
When the jargon starts to feel heavy, I love this quote from the foundational textbook by Aho, Lamb, Sethi, and Ullman. They wrote, "The goal of bottom-up parsing is therefore to construct a derivation in reverse." That brilliantly illustrates our journey here. You're taking the final, sprawling, chaotic source code that a human wrote, and you're just slowly walking it backward. You reduce it step by step until you reach the simple, single starting root. It's literally an exercise in reverse engineering chaos into perfect order.
As a student or a developer, there's a really powerful lesson in this architecture. You absolutely do not need to hold the entire, massive parse tree in your head at once. I mean, the parser certainly doesn't. To succeed here, you just need to focus on your next shift or your next reduce. If you follow the simple rules right in front of you, the largest structure takes care of itself.
Code can be messy. Projects can be overwhelming. But the next time you face a dense wall of code, remember this calm, steady rhythm of bottom-up parsing. You don't have to build the whole tree at once. Just shift the next piece into place. Recognize your handles, make your reductions, and ask yourself, what structure will you build from your leaves today? Thanks so much for joining me for this explainer. Keep learning, take a breath, and just take it one step at a time.